So for video 4, we're going to look at how to find coterminal angles. So before we do that, first we want to identify how we measure angles in trigonometry and in mathematics in general. So angles are going to have an initial side, a side that you start from, or you can think of this as a side that from which you rotate, and you're going to rotate through to some terminal side. So you're going to have an angle theta with an initial side and a terminal side. And in math what we do is if that rotation from the initial side, so for example here's an initial side, if we rotate through counterclockwise, then we're going to identify that as a positive angle. So 330 degrees means rotate 330 degrees counterclockwise. Whereas if we start at an initial side and we rotate through to a terminal side clockwise, that's going to be indicated with a negative sign. So negative is always in trigonometry going to indicate that you have a clockwise rotation, and a positive angle is always going to indicate that you have a counterclockwise rotation. So now that we've done that, we can talk about the idea of coterminal angles. And all a coterminal angle is any angle that starts at the same initial side, so you have to have the same initial and the same terminal. So here is an angle, for example, 330 degrees, positive because it is a counterclockwise rotation, starting at this initial side and ending at this terminal side. That angle is coterminal with negative 30 degrees, which starts at the same initial side and ends at the same terminal side. So those are coterminal angles, and what we want to identify is that if we have any angle theta, if we are at the terminal side and we rotate another 360 degrees, we wind up at the same spot. Similarly, if we were to rotate from this terminal position negative 360 degrees, so a 360 degree clockwise rotation, we would wind up at the same spot. In fact, as long as we are rotating integer multiples of 360 degrees, there's 1 times 360, there's 2 times 360, there's 3 times 360, gets us back to the same spot. So the general idea is for any angle theta, if that angle is measured in degrees, you will generate a coterminal angle by adding 360 degrees to that angle, or any integer multiple of 360. So theta plus 360 times k will generate a coterminal angle as long as k is an element of the integers. So integer multiples of 360. So this symbol here, z with the double bar, Zollen, just represents in mathematics integers. So your 0, plus or minus 1, plus or minus 2, and so on and so forth. If you are working in radians, then things are a little bit different, because if you're in radians, 360 degree rotation is equivalent to 2 pi radians. So in radian world, so this is degree world. So in radian world, the concept is the same. You need to rotate a full rotation, or 360 degrees, but a full rotation in radian world is 2 pi radians. So in radian world, if I have an angle measured in radians, I take theta plus 2 pi times k, again where k can be any integer that you want. So here's an example. So find a positive and a negative angle that are coterminal with 70 degrees. So a 70 degree angle, if this is an initial side and this is a terminal side, 70 degrees would look something like this. And to get a positive angle that is coterminal with it, I just need to rotate another 360 degrees to wind up back where I began. So there's a sense in which in degree world, every angle that is coterminal with 70 degrees is going to be an integer multiple of 360 degrees. So if we're doing this with a little bit more detail than maybe is necessary, what I could say is, hey, if I let k equal 1, then I get a positive angle coterminal with 70 degrees. So I get 70 degrees plus 360 degrees times 1 is going to give me 70 plus 360 is going to be 430 degrees. So 70 plus 360 gets me back to that same terminal position again. To get a negative angle that's coterminal, I would start here and rotate around the other direction, in the clockwise direction. So to get that clockwise rotation, I'm just going to take the 70 degrees and go plus 360 times, here we'll let k equal negative 1, which really gives us 70 degrees minus 360 degrees, which is going to give us a 290 degrees with a negative in front of it. If we're working in radian world, so let's say we want an angle that is coterminal with 5 pi over 6. So here's the big question, where is 5 pi over 6? How would you draw that angle? Well, remember, in radian world, 2 pi represents 1 full rotation. So if I divide that in half, that gives me half a rotation. So we know that pi is a half rotation, and this really says that you have 5/6 of a single pi. So you would take pi, this upper half rotation, or this 180 degree rotation, you would say, well, I have 5/6 of that. In other words, if I cut this upper chunk into 6 even pieces, 1, 2, 3, 4, 5, 6, I have 5/6 of a pi if I stop right here. So 5/6 might look something like this. Start with an initial side, rotate through to a terminal side, and we'll call that 5/6 of a pi. And then the idea is simply that every coterminal angle with 5/6 pi is going to have to look like 5/6 pi plus 2 pi is the same as rotating 360 degrees times k, any integer multiple of that. So to get a positive angle, just let k equal 1. Sorry, just let k, get rid of that eraser, let k equal 1. If we do that, we get 5/6 pi plus 2 pi times 1. And you need a common denominator, so we're going to multiply 2 pi times 6 over 6. So we'll get 5 pi plus 6 times 2 is 12 pi, all over the common denominator of 6, which is going to give us 5 pi's plus 12 pi's are 17 pi's. That's not writing on the bottom of the page. It's going to give us 17 pi's over a 6. And to get a negative angle, we just need to rotate from here anti-clockwise or counterclockwise. So in that case, we'll just let k equal -1. That'll give us a 5 pi over 6 plus 2 pi times a -1. Again, get your common denominator. And that's going to give us 5 pi minus 12 pi all over 6. And 5 minus 12 is going to be a -7 pi over 6 to get our negative coterminal angle.